Here it's integrated 3. It's your lecture for 10.1.5. And 10.1.5 is just giving you some practice in graphing your conic sections that you already went through, and you found the graphing form for all the conic sections, like the circles and the parabolas and the hyperbolas and the ellipses. So I'm going to go ahead and go through and do a couple. I want to do a parabola, an ellipse, and a hyperbola for you, just so that you'll see what all it entails to make a decent graph of these. So it's asking us. So I'm following problem 1093. It was going to have you do a whole bunch of different conic sections. I'm just going to do 3 of them. It says you need to include all of the key information, such as the locations of the foci and or the equations of any asymptotes. Use the following equations as examples for the builder. Oh, there was some context to this. But I'm just going to go through and show you how to get all this information. So here's a parabola. I guess that's the second problem. It's a parabola. And I recall that we found the graphing form of a parabola was y minus k equals a times x minus h squared. And we also found out that a, which is usually our stretch factor, is equal to 1 over 4c, with c being the distance between the vertex and the focus. So this part you probably know how to do. You just do it completing the square. So these are the x terms, and I added that 4 in there to complete the square, because half of negative 4 is 2, and 2 squared is 4. And I added a 4 on this side. And then these are the y terms. Oh, well, no, I brought these 2 over to the other side. And then here I have a perfect square, x minus 2 squared. And then over here I factored out a 4. So I'm just trying to get it into this form right here. So that's why I'm doing all this. And then I divide both sides by 4, because I'm trying to get that y kind of by itself. So that's where that 1/4 came from, divided both sides. And then I'm used to seeing the k, like x minus h and y minus k. I'm used to seeing k on the other side for some reason, so I just put my 5 over here because it made me feel more comfortable. You can leave it like this if you want. That's how your book's doing it. And so then the first thing I do when I want to graph these is I just look for the center. It's x minus h. Well, there's h and k, so positive 2, positive 5. So I just go 2, 5, I make a dot. And then I know it's going to be an upward facing parabola because the x is the squared one, and this is a positive number. But I kind of need to, like, I know I can see that the stretch factor is 1/4, but I kind of need to, in order to graph it, I need to know a little bit more, like just plug maybe 1 point in. So I tried plugging 0 in for x, just to see if that was an easy one for me to get a point. So if I put 0 in for x, I get negative 2 squared is 4, and 1/4 times 4, well, that's 1, plus 5 is 6. So that's a very convenient point for me to have. And I know that there's symmetry. This is a line of symmetry, so I know there's another point right there. So that's plenty for me to get the shape of the graph. Then all I need is the focus. I found the focus to be right there, and the way I do that is I know that C is the distance between the vertex and the focus. So I solved for C by going, remember A is our stretch factor, and A is equal to 1 over 4C, and C is the distance between the focus and the vertex. So I just set 1/4 equal to 1 over 4C, and I don't know if you can see that, but C's got to equal 1. So I knew that the focus was going to be on the inside of the parabola, so I put it up by 1 from, I make this distance be 1. And then they wanted me to label all these things. So my focus ended up at 2, 6, and my vertex ended up at 2, 5. And then this is my directrix. I don't know if you remember that, but the directrix will be equidistant from, like, here's my vertex. If this distance is 1, this distance will also be 1. Sorry, it's not drawn to scale. And that'll be my directrix. And so the directrix always has a line like y equals something, or if it's a sideways parabola, it would be x equals something. So there's all the information that they're asking for. That's your parabola. I think I'll do the ellipse, and then I'll do part 2 for the hyperbola. So here's the ellipse. There's my equation of an ellipse. And so I went through here and I did completing the square. These are my x terms. I realized that 16 times 6 equals 96. So I had it, I had a blank spot right there. And then I said, well, what can I complete the square with? Well, half of 6 is 3. 3 squared is 9, so I added a 9 here. But what I had to add over here wasn't a 9. It was whatever 16 times 9 is. So that's where that 144 came from. And then likewise over here, the 84 I brought to the other side. And over here, I factored out a 5. And then I asked myself to complete the square. Half of 4 is 2, and 2 squared is 4, so I'd put a 4 in here, which really the value of it was 20, because 5 times 4 is 20. And then when I add all these up, I get 80. And this right here turned into x plus 3 squared, because it's a perfect square now, and there's my 16. And then this turned into y plus 2 squared, and there's my 5. But when I divided everything by 80 to get the 1, I was able to do some fraction math. It turns out that 16 times 5 is 80, so 16 goes into itself once, it goes into 85 times. That's where this 1 and this 16 came from, so that's where this comes from. Now I can get my center. I've got x minus h, so that'll be negative 3, comma, negative 2, I suppose. So 1, 2, 3, 1, 2, put my center in there. And then I'm going to look at this 5, and this is going to tell me how far to go on the right and the left of the center. So this is a squared. So a is actually square root of 5, which I found to be 2.2. So I went right by 2.2 and left by 2.2. And I'm going to go up and down by 4 because that's the square root of 16. Okay, and then I just formed my ellipse. And then I needed to find the foci. So I remembered that we learned that a squared minus b squared is c squared. And so a squared, I can look right here and I can see that it's 5, and b squared is 16. So, oh, sorry. A is always the bigger number. I'm sorry. A is always supposed to be the bigger of the two numbers. So this is B and this is A. But I mean, I guess you figure that out when you, or maybe you don't. You take the bigger number squared minus the smaller number squared. So it's going to be 16 minus 5 is c squared. And then so C ends up being square root 11. So this actually, since the smaller number was under x, we would call this variable b, and we would call this a. Okay, I mean, it works out. Just keep it straight in your head that you have to subtract the smaller number from the larger number. That's equal to c squared. And then, so square root of 11 is about 3.3. So I know that my foci are going to be on the same line of symmetry as my center, and that's the major axis right here. So I'm going to go up by 3.3 and down by 3.3 and place my two foci there. And then so when I label it, my x value, or my x coordinate, is going to be at -3, but my y coordinate is going to be -2 plus root 11, that's this one, and -2 minus root 11, that's this one. So you have to give that information. This one doesn't have any asymptotes or anything. So it's a long chore to do all that. Part 2, we'll do a hyperbola.